In this video you will learn about the 6 inverse trig derivatives, both how to find each of them, starting with just a simple equation and using implicit differentiation and a triangle, and then also just memorizing patterns to help you remember it, and then some applications with like the product rule and the chain rule and that sort of stuff. The first inverse trig derivative that we'll look at is y equals the arc sine of x. You might also see this written most commonly in your calculator as sine inverse of x. And here the negative one, just like it did in the last in earlier section, means inverse, not 1 over sine, because that's cosecant, and it doesn't mean like inverse derivative or anything like that. I'll be using this notation since that's what will most likely show up on things. Well, if y equals arc sine of x, eventually what we're looking for is y prime. So, well, we can't really do much, or can we? Yeah, we can actually. If y equals the arc sine of x, remember that arc sine is an inverse function. It's sort of like undoing sine. So really what this means is that the sine of y equals x. Okay, so if I take this equation, if I take the arc sine of both sides, then the arc sine and the sine will cancel, and I'll be left with arc sine of x, just like it says up here. So what we're going to do is we're going to start with this relationship. Check it out. So the sine of y equals x. Well, I'm just going to use implicit differentiation. The derivative of sine of y is cosine of y, chain rule, y prime, and the derivative of x is just 1. That was easy. Sweet. Alright, so y prime equals 1 over cosine of y, and if I really wanted to simplify this, I could say secant of y. But now it seems like we're stuck, because I have my derivative, but it's only in terms of y and not x. We'd really like to have it in terms of x. So how do we do that? Good question. The answer comes from our definition here. It's not really a definition, it's what we started with. We have sine of y equals x. Let's break this down. Well, whenever we're using sine, we're probably talking about a right triangle. Okay, there's a right triangle. If I'm taking the sine of something, that something has to be an angle, right? So you can't take the sine of, like, a house. That would be weird. Okay, you take the sine of something in degrees or radians, that makes a lot more sense. So this y is an angle. Let's put it there. Looks good. Notice that I'm just kind of making this triangle up as I go. Alright, sine of y equals x. Well, technically that's like x over 1. And if you remember, like from when you went to Camp Sokotoa, that this is the opposite and this is the hypotenuse. Well, let's put those on our triangle then. Opposite is x, hypotenuse is 1. How do I find that third side? If you were thinking, let's Pythagorize it, that's probably right. Great. So this side is the square root of 1 minus x squared, because I did 1 squared minus x squared and square rooted it. Cool. Alright, so big picture. I had to find this cosine of y, right? Well, I have y, and I have a right triangle with an adjacent side and a hypotenuse, so I can find cosine of y. Cosine of y equals the square root of 1 minus x squared over 1, which is just 1 minus x squared. So I'm going to plug this in for cosine of y. So I get y prime equals 1 divided by the square root of 1 minus x squared, like that. So if we bring this back to the original problem, we get, yay! The derivative of the arc sine of x equals 1 divided by the square root of 1 minus x squared. I just want to take a moment to explain how kind of weird this is. Explained before with like the whole unit circle that in pre-calculus you learned how like triangles and circles are related through pre-calculus and the unit circle, and the fact that sine and cosine both have to do with the unit circle and with triangles. Here I'd like to point something out. Here, check it out. Sine has to do with like circles and triangles and stuff, and this 1 over 1 minus, or square root of 1 minus x squared, first of all, that's algebraic. That's not trigonometry at all. So we're relating something that's trig to something that's very clearly algebraic. Furthermore, there's like a square root in there, so we're just like throwing all the shapes in there. Like, whoa, watch out for like octagons and stuff, right? Okay. There are, of course, 5 other inverse trig functions, so arcsine, arctangent, cotangent, arcsecant, and arccosecant. Yeah, those are all fun to say. And it's left as an exercise up to you to find out what all of those are. No, not find out, but like show me using this method, so drawing a triangle and doing all that jazz. Your triangles will be different probably for each of the ones that you do. But here are the rest of the rules. So we have arcsine, and that's the one we just got. And then arccosine is pretty much almost exactly the same. The only exception is this negative up here, so you do have to watch out for that with arccosine. And arctangent is probably the one that's easiest to remember because it's just 1 over x squared plus 1. And then check it out. Hey, that arc. So the c's, just like with regular derivatives, cosine goes to negative sine. Cotangent goes to negative cosecant squared, and cosecant went to negative cosecant cotangent. Here, the arc cosine goes to negative, the arc cotangent goes to negative, and if your guess is that the arc cosecant of x goes to negative, you're probably going to be right. And there's the last pair, is the arc secant. And arc secant, yeah, it's kind of weird. We got more stuff going on because we have this like absolute value of x going on underneath. Kind of weird. And then we have arc cosecant, which apparently 50% of the letters there are C, but that's okay. But check that out, that negative is still there. And so I kind of like to remember these. If you switch the order of arctangent and arcsecant, like just switch the order, then it goes from like least complicated to most complicated, because this is just a fraction. This is a fraction with a square root, and this is a fraction with a square root and an absolute value. So that's how I kind of remember which is which. However you want to remember it best is totally up to you, but you got to know them. Sorry. All right, let's practice a little bit. Let's take the derivative of 3 times the arcsine of x minus 4. So, well, the 3 is multiplied and it's constant, so that's just going to like hang out and be multiplied. Remember, arcsine is 1 over the square root of 1 minus stuff squared. Okay? Now in this case, it's not just x, it's stuff. So we have to put in x minus 4 into the stuff and then chain rule the stuff. The derivative of x minus 4, though, is just 1, so that is your answer. And it's basically, I mean, it's kind of weird because there's like square roots and stuff going on, but you don't have to simplify it, you just kind of leave it like that. Go on your business and do the next problem. Alright, let's take the derivative of the arctangent of x cubed. Well, this is going to be, there's nothing multiplied up front, so this is 1 over, and an arctan was 1 over 1 plus stuff squared. Alright, well the stuff is the x cubed, so we're going to put in the x cubed there, and then we're going to, that's a 3, we're going to chain rule that x cubed and get a 3x squared. And so you might see this simplified as 3x squared divided by 1 plus, and then here if you do have an exponent to an exponent, that's when you multiply. So it is x to the 6th, like that. And of course it still works with the product rule, so that's why we have x times the arcsecant of x. Label it your f and g, so we're going to do f prime g plus g prime f. Well, f prime is just 1 since we're taking the derivative with respect to x, so it's 1. G is the arcsecant of x. And we're going to add the derivative of arcsecant of x, which is 1 over the absolute value of x times the square root of x squared minus 1. And then multiply this by x. Okay? And now you can't cancel these two x values, the x divided by absolute value of x, because it depends on the value of x. If x is negative, then when these cancel, you'll be left with a negative 1. But if x is positive, then you'll be left with a positive 1. So it depends on what x is. To be safe, leave it, and that's your answer.